Topic A, classes, objects, and their attributes. Now, let's start having a look at the object-oriented paradigm. I'm going to attempt to explain it myself in a really brief manner, which is almost impossible, and then I'll follow that up with a quote from Steve Jobs. Now, personally, the most intuitive way that I can understand the concept of a class, which makes objects, is that a class is like a template or a blueprint to make an object. So what is an object then? And what is in a class? Well, in a class are a set of attributes that each object is going to have. These are like facts about that object. And there's also a number of methods, usually. Now, methods are functions that the object can perform. So then the class is used as a template from which you make multiple objects. So you could have a class K. The class is going to have attributes like the weight, the dimensions, top speed, or something. It's also going to have methods. So depending on, if you're in the factory, the methods could be change tires, check oil, or if you're in a dealership, in which case the methods is the price, the markup, etc. Now, let's look at what Steve Jobs had to say about objects. I assure you it's a lot more poetic than me, so I hope you find it useful. Objects are like people. They're living, breathing things that have knowledge inside them about how to do things. And they have memory inside them so they can remember things. Attributes, variables. And rather than interacting with them at a very low level, you interact with them at a very high level. The sort of low level versus high level simply indicates that objects could have information in them that you do not have to understand. You do not have to understand the mechanics of what's in an object to use those objects for whatever you need. So let's look at some advantages of the object-oriented paradigm. First of all, it makes code reusable, and we looked at functions before. They make code reusable. However, classes and object-oriented programming make that step up to the next level. So, for example, let's say I talked about the class K. Let's say you have a class K, and a K has certain attributes. Now, you want to do Jeeps. Well, Jeeps can inherit attributes and methods from Ks, but also have their own thing. So you can basically recycle both variables and functions that are neatly packaged together. Now, it's very intuitive for real-world projects. It was designed to handle real-world projects. So especially projects that involve data about, say, a person. Like, you could have a company HR system is going to have a person object, and a person is going to have a contract, a salary, contact details, position, and these are attributes of a person. There's also going to be actions related to the person, like you can message them, you can send them on leave, etc., etc. Next, code is easier to test, debug, and maintain. Certainly, if done right. What you have is an effect where the classes themselves, the way they're structured, they indicate how best data within them should be used. And this is easier for both testing, and it is easier to manage sort of larger systems. Because, say, in Python, you have 20, 30 variables that could be in a very, very large object. However, if you want your users to only change 4 or 5, then you can sort of build that into your class so they don't have to worry about it. So certain data can be hidden, and the user can only see and interact with what they're going to need to use. So let's finally have a look at, in Python, how we create an object. That is the simplest way I can think of. You basically create a class, inside there you have a pass, and then all you need is to instantiate it by basically saying variable name equals to class name, open close brackets, you have a Jack object. Now Jack is a person. A person at this point has no attributes, no methods, but we can add those. So let's have a look here. at something that every object has in Python. You can basically say object name.dict with this. These are called dunders, double underscore. And that's going to give you this dictionary in which your attributes are going to be written, but we don't have any. However, we can add them. So for example, just by saying, this is the object name, you can add an attribute name and then assign a value to the attribute name. So now we've given our person object a name, an age, a height in centimeters. And if we print the person.dict, you're going to have a dictionary with this data, age, height in centimeters, and name. Dictionaries being unordered, age comes first. And you can also basically print person.name, person.age, person.height in centimeters. Alright, so enough about lecturing about this. Let's get into code and have an example of a car object. So in this video, we're going to take a little detour. I mean, we looked at a person as an object, and now we're going to look at a car. So just to give you another little perspective on how we can use object-oriented programming. And I'm just going to create a bare bones car class. Then we're going to create some car objects. I guess I can do 2. And then we're going to add attributes and print those out. So let's get started. So the bare bones of a class is literally this. You remember to use capital letters for the class name, no parameters, and nothing in it. Pass. That's it. That's the minimum. I should have called it class minimum, but then I don't know what attributes the minimum has. Anyway, so now we can create cars. We can just say, ooh, Honda equals to car. Mazda equals to car. Now, we can add attributes. We can basically say Honda.model equals to something, some value. I guess we can do a string. CRV, that's a Honda model. And we can say Honda.weight, and that could be, I don't know, cars weigh about a ton, 1200. So we have these car objects. One of them, the Honda, has got 2 attributes. So now how do we print them? Well, there's 2 ways you can print them. You can print the individual attributes, basically say Honda weight, and then print like that, comma, Honda dot weight. So let me run this. Honda weight, 1200. You could have done the same for Honda model. In fact, maybe Honda model can go first. And there's an I in weight, by the way. Honda.model. So that would work as well. But there's another way to do it, which is Honda.dict. And that's basically going to print the dictionary of the attributes of the object Honda. And if we did the same for the Mazda car, you're going to find that there's nothing in that dictionary. So we should just get a blank dictionary. So there you go. Simple example of creating objects, adding attributes to